Okay, in this lesson we're going to be looking at Pascal's triangle as a way of expanding, multiplying out a plus b to the nth power. This is a pretty short lesson here. Let's look at patterns. Math is a lot about examining patterns and seeing if it extends out. So we have a plus b to the 0, that's 1. A plus b to the first power, that's equal to a plus b. We keep on going here. This is our perfect square binomial. Perfect cube here, a plus b cubed. We saw this in a previous lesson. A cubed plus 3a squared b plus 3ab squared plus b cubed. And I'll just show one more. This is an expanded version of a plus b to the fourth. Now, the key thing to look at is these coefficients here. That's one thing. And there's kind of this cool pattern that's kind of emerging when we look at each of these coefficients here. When we look at it, it looks like there's something interesting where you see here the 3 is the sum of the 1 and the 2. The 4 here is the sum of 3 and 1. The 6 is the sum of 3 and 3. And, you know, if we made a little triangle, this is actually what's called Pascal's triangle. It's constructed where this number here comes from the addition of the two numbers there, and we can just actually generate the next row. 1, 6, 15, 20, 15, 6, and 1. How do we use it? Oh, one other thing to notice. Look, let's look at the kind of the variables now. A to the fourth, a to the third, a squared, a first. So it's decreasing the exponent. 4, 3, 2, 1, and if you would, you could think of a to the 0 power being the last one. On the other hand, for the b term, you have b to the 0, b to the first, second, third, and the fourth. So it's very easy. There's a very nice pattern for the variables, and there's a very nice pattern that we could find for the coefficients using Pascal's triangle. So using this, let's expand a plus b to the fifth power. We're going to use Pascal's triangle, the coefficients that we pull out and we put right here. And then we're going to put in each of the variables in there now, according to the pattern. We have, you know, a to the fifth, a to the fourth, 3, 2, 1. And then we have b to the 0, 1, 2, 3, 4, and 5. And there we go. We've expanded out a plus b to the fifth power, and we can do that for any of the other ones as well. You know, if we want to go farther down, we could do the sixth one, a plus b to the sixth, using this set of coefficients here. So let's see how then we can now use this. Let's expand 3 minus 1 to the fifth power. Using Pascal's triangle, these are the coefficients of each of the terms. So I'm going to write that out, and then I'm just going to kind of put in my template of my a and my b. So in this case I have, you know, to the fifth power, fourth, a to the third, a squared, a to the first, and then this second parentheses term here is my b to the first, b to the second, b to the third, b to the fourth, b to the fifth, and now I'm just going to populate the a's. In this case, a is my 3y, and I'll populate my b's. b is negative 1 right here. And I put that into the here, and now I'm going to take my next step of just simplifying it all out. And this is how we have used Pascal's triangle to expand out some term like this. So going back just 1 second to the previous slide, you know, in the previous lesson I was talking about the pattern for a plus b to the cubed as being this 1, 3, 3, 1 pattern here. So if you can connect it to Pascal's triangle, you can kind of remember the cube pattern fairly easily from that. And you can, in fact, generate any of them from Pascal's triangle. So go ahead and, actually, here's the answer. I shouldn't have showed the answer. I'm going to erase it real fast. You could expand out these using Pascal's triangle, and I'll show you the answer right here. Okay? There you go. Have a good day, everybody.